Hey there, algebra students. We're going to do a little practice with rewriting formulas, or sometimes it's called solving literal equations. And so you'll look at a problem that says something like solve for y, and then you'll get this crazy looking thing that says something like 4x plus 3y equals, we'll say 13 for whatever reason. All right, and so when it says solve for y, that means, just like it's always meant, get y by itself. And so you need to have y all on its lonesome, and everything else that's over there with y needs to move to the other side somehow or other. And so we need to get rid of this 4x, and we need to get rid of this positive 3, and we need to do a couple things in order to make that happen. If we do that, we'll end up with an answer that says something like y equals, and that's our hope. So we're trying to move towards that y equals solution. So just like before, if we're trying to solve for y needs to stay put, and we need to try to move everything else around. And so I'm going to start by moving the stuff that's furthest from the y, and right now that stuff is 4x. And so I'm going to take away 4x from both sides. Because if I subtract 4x from 4x, it gets rid of it there. I'm left with 3y on the left, and I get something like 13 minus 4x over here. Now some students want to write something like 9x here, and you might think that that's the right answer because 13 minus 4 is 9, but 13 and 4x are not like terms, so you have to be very careful about that. All right, so now we need to get rid of this 3. It's sitting there right next to the y. In order to undo that, I need to divide by 3. And so I'm going to end up with this statement that y is equal to 13, I need to divide both sides by 3, minus 4x over 3. Now we take an additional step here, and that's that when you have the entire side divided by 3, you can break up that division by writing it as 13 over 3. We divide 13 by 3, but we also divide 4 by 3. And there's our complete answer there. And we've solved for y. Y is by itself, and we have it, and this is sometimes called in terms of x. All right, so that's one example. Let's look at another example briefly. Then we'll look at a third one that's sort of the most difficult kind of solving for y or x that we'll look at. So I might have something that says solve the uniform motion equation or formula for, let's say, t. And the uniform motion equation is something like x sub f, which is just the variable x sub f. It's just one variable. The f is a subscript. And then you have x0, where you start, plus vt. All right, so again, we need to try to get rid of the stuff that is over here with t. And so we're going to try to get rid of the x naught, and then we'll also try to get rid of the v so that the t can stay right where it is. So we need to end up with an answer. Since it says solve for t, we need to end up with an answer that says t equals, where t is all by itself. So the first thing I'm going to do, I'm going to get rid of the thing that's furthest from the t on the right side of the equation, and that's the x naught. And to get rid of x naught, I need to subtract it. I take away x naught. And so that gives me xf minus x naught, because those are different variables, because they have different subscripts, equals, this cancels out, and I'm just left with vt. And I still need to get rid of v. And so now I'm going to divide both sides by v to undo the times by v. And so I get xf minus x naught over v. Now you could break up that division like we did before, but since we're dividing by a variable, we might as well just leave it as it is. And so that's another example there that you might have to confront. And so the big idea is that we're telling you what to solve for, and that was t in this case, which means we need to get t by itself. And we need to take the same kind of steps you would if these were just numbers. So just consider for a moment if I had written 10 equals 4 plus 2t. I would have gotten rid of 4 just like we got rid of x naught. And so I'll do a little highlighting here. This step is just exactly like this step. We're taking the exact same step. 10 minus 4 was 6 equals 2t. And now I'm going to divide by 2. divide by the thing that's next to t. And that step is exactly, whoops, I meant to change the color there, is exactly like this step of dividing by v. And so again, you get t by itself, but it's all on its lonesome there, and it's equal to 3. When we had numbers, we're able to come up with a single answer for t. When we don't have numbers, we have this weird-looking thing that has a bunch of variables in it. So t depends on all those variables for its value. Let's look at one more thing that might be the most complicated version of what we might ask you to do with this. Let's say we said solve for y again, and we had an equation that was 3x plus 4y equals 10y minus 2x. And we can say plus 5, why not? So to solve for y here, again, we need to end up with something that says y equals all on its own. And so in order to do that, I noticed that there are y's on both sides of the equation. And so just like before when you had variables on both sides of the equation that you wanted to collect to one side, you need to start by subtracting those or adding them. So I'm going to take away 4y here. And so I get 3x is equal to 6y, because 10y minus 4y is 6y, minus 2x plus 5. And now I have all of this stuff to get rid of. And so I'm going to start by getting rid of the plus 2x. Sorry, the minus 2x by adding 2x. So those will cancel out. 3x plus 2x is 5x is equal to 6y plus 5. Now I'll get rid of the 5. I'm not going to have enough room here. I'll keep moving down. I get rid of the 5. Those cancel out. So now I have just 6y on the right side of the equation. And then I have 5x minus 5 on the left. Now y isn't totally by itself yet. I still have a 6 there. So I'm going to divide by 6. And so I get y is equal to, and now I'm going to break up that division, 5/6 x minus 5/6. And now y is totally on its own. And we started off with something really complicated, but again, we just use the tools that you guys have already developed. And we're just expanding what we're able to do with those tools. And this is sometimes called manipulation or algebraic manipulation. It's a really useful skill in science because this is how new formulas get derived in a lot of cases. You play with old formulas until you see something new happen. And this is the way you play with them. You just move x's and y's around until you solve for a new variable. So hopefully that is a little elucidatory, if that's a word. I don't know that it is. And you have a little bit better idea what to do when you're confronted with a problem like this.